Hello everyone, welcome to my YouTube channel Zenith GATE Mechanical. Continuation with the concept and question series.
So the today topic is free body diagram. Free body diagram. In case of free body diagram, so it is basically a diagram in which you will show various type of forces. Once you will isolate the body from all the type of contact. So free body diagram is nothing but it is a diagram which shows various forces acting on the body, acting on the body after isolating the body from all the type of contact, from all contact. For example, so let us suppose a ball is there which is resting on the horizontal surface. This is the ball which is resting on this horizontal surface. Okay. Now, for drawing the free body diagram, what you will do, first of all, you will remove this contact and you will apply the forces which is acting on this ball. So this is the first case when the ball is resting on a horizontal surface, on a horizontal surface. Okay, so suppose if I want to draw the free body diagram of this body, this is a ball. So what are the different forces which is acting on this body? The first one is the weight of this body which is acting in downward. So this is W. Now there will be a normal reaction because this body is making a contact with this surface. That means that there will be a normal reaction which will act in the upward direction. Okay, so this is, let us suppose, the normal reaction is R. So this is the free body diagram of this particular body. Let us take some other examples. The ball which is hanging by a string and supported by a wall. Okay, so this is the case. There is a wall and this ball is hanging. This ball is hanging with the help of one string. And this ball is making a contact at this point. So how you will draw the free body diagram? Again, just eliminate the contact of this ball with the wall and apply all the forces. So this is the ball in which there is a force, tension force, which is acting in this direction. There is a contact between these two surfaces. That means a ball and wall. That means there will be a reaction. So this will be nothing but a reaction. Now, again, I'm considering the weight of the ball is W. So it will act in downward. So this is the free body diagram of the ball which is hanging with the help of a string and supported by a wall. So that means in most of the problem, what you will do, first of all, you have to draw the free body diagram. Once you have a good understanding of how to draw the free body diagram, that means 90% of the problem is solved. Okay, so that means you have to use the equilibrium equation, which I have discussed earlier in my classes. That means summation of force in x direction 0, summation of force in y direction 0, and take the moment about any point will be 0. Okay, so let us suppose one more example. Again, the ball which is resting between two inclined wall, two inclined wall. Okay, so these are the two inclined wall, and there is a ball which is resting in between these two walls. So suppose if I want to draw the free body diagram of this particular body, which is nothing but ball. So this is ball. What are the forces which is acting on this body? First of all, there is a contact between these two points. That means there will be a normal reaction here and here also. And one is the weight of this body. So this is one normal reaction. So I'm denoting with the R1. Similarly, here is another normal reaction. Let us suppose this is R2 and the weight of the body which is acting downward, which is nothing but W. Okay. Now, the fourth example I'm taking as a ladder which is kept against a wall, against a wall, and I'm also considering the friction. I'm also considering the friction which is exist at both the wall and floor. Okay, so this is basically a ladder which is resting on this horizontal and inclined surface or vertical surface. This is basically a ladder. Okay, so which is resting on these two surfaces. So how you will draw the free body diagram? And I'm taking the weight of this ladder is W. Okay. Now, one force is nothing but the weight of this ladder, which is acting in downward. There will be a contact force here. So that means there is a contact, that means there will be a reaction. So that reaction is R1. So if you see, this ladder has a tendency to move in this direction. So the friction force will act in the opposite direction. So the friction force is in this direction. So let us suppose this is F1. Similarly, there is a contact. If there is a contact, then there will be a normal reaction. This is R2. And there will be a friction, which is nothing but the F2. Why the friction is acting in upward direction? Because this ladder has a tendency to move in downward. So this point is trying to move in this one. The friction will act in this direction. Similarly, this point has a tendency to move in this downward direction. So the friction force will act in the upward direction. Okay. So this is the free body diagram of ladder, which is resting on the wall and the floor. And there is a friction also present. Now, the last example I'm taking for the free body diagram is nothing but two block system. Two block system. So there are the two blocks, the block A and the block B. The block A is resting on the block B, and this block B, which is resting on this surface. So this is the block B and this is block A. So I'm denoting this block A as a first body and this is the second body. Okay. Now, for free body diagram, first of all, what you will do, you will isolate the body A from the all the type of contact with the B. Similarly for the B also. So this is the block A in which one force will act in downward, which is nothing but the weight of this block A. And there is a normal reaction R1. What is this R1? R1 I am representing here the force which is exerted by the body B on body A. On body A. So because there is a contact between these two body, So this B body will exert one force on the body A in the upward direction. And the same force which will be experienced by the block B due to the block A, because this is the nothing but Newton's third law. Now, this is the free body diagram of block A. So if you want to write down the summation of force in y direction, that means WA is equal to R1. That means the reaction which is acting between the surfaces of contact between the block A and B is nothing but WA. That is the weight of the block. Similarly, if I want to draw the free body diagram of this block, so there will be a normal reaction which is acting in downward, and this reaction is nothing but exerted by the block A on the block B, and this reaction is exerted by the block B on the block A. Both are equal in magnitude and opposite in direction. Okay, so one more force will act, which is nothing but the weight of this block WB, and there is a reaction. So I'm assuming, let us suppose the reaction is R2. And what is R2 here? R2 is nothing but the force exerted by ground on body B. Force exerted by the ground on the body B. Now, can I write R2 is equal to R1 plus WB? Okay, and R1 you already know, which is WA. That means the total reaction which is offered by the ground on the block B is equal to the total weight of this block. That means the weight of block A and the weight of block B. Okay. So now you understood how to draw the free body diagram.
I hope this series truly help you in your exam preparation. So don't forget to like, share, and subscribe. Thank you so much.